Hello and welcome to my channel. I am Mensa Augustine. In this lesson, we'll be looking at a circle theorem, that is Euclidean geometry, and we will go through 10 examples. I have the first 3 on the board. I have 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, and this is the first 3 that I've drawn on the board. Now, if you are preparing for any exams like WASI, NOVDEC, if you are preparing for GCSE or any other related exams that may need the circle theorem, this video will help you. So watch the video, like it, comment based on your experience, and also share. Remember also to subscribe to my channel. Now, if you have any question related to this, you can contact me or you can WhatsApp me to my WhatsApp number +233 245360793, and I will be of help to you. Now, let us start doing something. Okay, let's start from the first question. Now, when you look at the first question, you have to find angle T, where O is the center. So O is the center. Now, how do we calculate for T? I have this 35 here. Will it help me to calculate for T? Oh, okay. Let me look at this chord. This chord subtends angle 35 here. And the chord also subtend this angle here, so it means that this angle and this angle are the same. But still, this angle cannot help me to find the T because I still need this angle. But let us look at the chord, this chord. This chord subtends angle T here, and this chord, this leg goes here. So let's join this one to this. Very simple as that. When we join it, this angle and this angle become what? The same, because they are from the same chord. This chord has formed this, and this one has formed this on the circumference in the same segment. So the angle here will also be T. Now let us utilize the property of the diameter. Now this line is the diameter, and we are saying that the diameter forms an angle of 90 at the circumference. So it means that the angle that the diameter has formed, this angle is 90 degrees. That is 35 plus T equal to 90 degrees. And T will be equal to 90 degrees minus 35 degrees. And T will be equal to 55 degrees. Wow, that is it. Now, yes, it's 55 for emphasis. Let's go to the next question. Now, this question, we have to find this angle, Y. So how do we calculate for angle Y? We have 130 degrees there. So, for that 130 degrees, what do we do? We have line QR being parallel to line TS. We have that power line there, so we can choose to do alternate, or we can utilize the power line property. So here, the first thing that we can do is that we can add this to what we have here, that is co-interior angles. If you have this line and their power, then the angles here are called co-interior. They sum up to 180 degrees. That is from Euclid, the father of geometry. So let me put, let's say A here, angle A here. So we are going to get, let's do it here, 130 plus Y plus A equal to 180 degrees. So here, we want angle A. So angle A will be equal to 180 degrees minus 130 minus Y. So angle A will be equal to 50 minus Y. Wow, that is our angle A. So now let's decline A and put 50 minus y there. Very simple as that. Now, this is the diameter. So the diameter subtends an angle of 90 at the circumference. So it means that this angle is 90. Now, this line is parallel to this line. That is QR is parallel to ST or TS. So the angle here and the angle here are alternate. They are alternate because this angle starts from the parallel line and ends on this line. And this angle will start from that line and ends on the parallel line. Now, what we are going to utilize is the property of the cyclic quadrilateral. Now, this quadrilateral is a cyclic quadrilateral because the endpoints or the vertices of the quadrilateral touches the circumference of the circle. So, you say that the opposite angles here sum up to 180 degrees. So, you write 50 minus y plus 90 plus y equal to 180 degrees. And that you have 50 plus 90 is 140. If you subtract it from 180, you get 40 degrees. Here, negative y will cancel positive y, and you have y equal to 40 degrees. Very simple as that. Let's go to the next question. Now, this question, we are to calculate for this angle x. Wow, we have to find angle x. Now, how do we calculate for angle x? We have 48 degrees. So 48 plus x plus this angle, we could have find x, but we don't have this angle, so we cannot use this triangle. Now, this line, see that it touches the circle at A. So it means that the line is tangent to the circle. So we can utilize the tangent property here. Now, the angle between the tangent and the radius of the circle, since this is O, is 90 degrees. So we can use that. So 90 plus 48 plus this angle, let me name it angle A. That is angle A plus 90 plus 48 will give us 180 degrees. Wow. So angle A will be, that is A will be 42 degrees. Let me put it there. That will give us 42 degrees. Very simple as that. Now that we've found this angle, we know that OA is radius and OC is also radius. Very simple as that. So if we put this angle to be M, this angle should also be M, because the angle OAC is an isosceles triangle and the base angles are the same. So let us find M. We take M plus 42 equal to 180 degrees. Sum of the angles in triangle OAC. And here we have 2M to be equal to 180 degrees minus 42, and M will equal to 180 degrees minus 42, all divided by 2. So let's use the calculator. That will give us 69 degrees. So we have M to be 69 degrees. Now that we found M, you see that the total angle here is 90, and M plus X will give us the total angle, that is 90 degrees. Wow. And we know M to be 69, so X will be equal to 90 minus 69, and X will be equal to 21 degrees. I hope this helps. That is, the techniques that we are using, or that I'm using, will help you to solve any circle theorem question, or most of the circle theorem question that you will encounter. Let's take the next example. I said I have 10 examples here. Now, this is the next examples that we have. Let me take the one that we've done so that I will not repeat them again. We did this, and which one? Yeah, we've done this one. So this is what we are going to do. Yes, we have to find the angle QSR. We have to find angle QSR. And here too we have this one. You are waiting, keep waiting, right? That this is I have here to be 35. You have to calculate for this y. The lines here are parallel. So let's take these two. And then after that, we will continue. Now, we have to calculate for QSR. Now, this one is pretty cool for us to do if you know this property. Now, check this property out. If I have a triangle, let me name here M, A, B, C. Now, sum of the angles in the triangle A plus B plus C, I'm going to do it A plus C, 180 degrees. Let me make AC the subject. You see that A plus C equal to 180 minus B. Wow. 180 minus B. Now let us take these two angles. They are also angles at a point here. They are adjacent and they add up to 180. That is M plus B is also equal to 180 degrees. And if I make M the subject, I'll have 180 degrees minus B. Wow. If I take B from 180, I'll get M. If I take B from 180, I'll get A plus C. So this implies that A plus C is equal to M. Wow. Let's assume that M is 10. 10 from 180. Sorry, let's assume that B is 10. B from 10 from 180, M will be 170. 10 from 180, A plus C will be 170. So that is A plus C equal to the M that we have here. So if you know this property, doing this one is very simple. Now we are going to use that property. That's 30 plus 40 is 70. Wow. So the sum of the opposite interior angles of a triangle is equal to their corresponding exterior angle. That is what we have there. Now, for this angle, you can join T to Q to get chord TQ. And see that this chord subtends this angle at the circumference, and it also subtends this angle at the circumference. So if here is 70, the angle here is also 70. And we are done because 70 plus QSR will give us 180. That is angles on a straight line. and angle QSR will be 110 degrees. Wow, very simple as that. But if you don't know this property and you want to find this angle in a different way, you take this 30 plus 40 plus this angle. So let's assume that this angle is T. That is 30 plus 40, that is 70, plus T will give us 180, and have T equal to 110. Then after that, we use T to find this angle, that is 70, and then we take these two angles. Wow. Now let's take the next example. Now for this example, we are to calculate for y. I'm seeing where y is, correct. Now don't say that y and 35 are alternate. No. This line and this line are parallel lines, but this line and this line are not parallel. So this angle and this angle are not alternate, because this angle starts from this line and ends on this. So it does not start from a parallel line. Are you okay? Correct. Now we can't do that. So what do we do? What we can do is that we see that this is the center of the circle, and from the central angle theorem, the angle at the center here is twice the angle at the circumference, right? Yes. So the angle here is 2 times 35, and we are going to get 70. Wow. After we have done that, this triangle, this is radius and this is radius, because this is the center of the circle. Now if this one happens, this triangle becomes an isosceles triangle, so the base angles are the same. So I'll name here angle M, and this one too as angle M. So I'll take M plus 70 equal to 180 degrees. 2M will be equal to 110, and M will be equal to 55. Wow. It means that the angle here is 55 and the angle here is 55. Now, we can use the alternate angles now. You see that this angle starts from this parallel line and ends on this line. The line that M ends on, this angle starts from that line and ends on this parallel line. This line and this line are parallel. So if here is M, this angle is M. So definitely we are going to have here to be 55. Now we are going to utilize the property of the diameter, that the diameter subtends an angle of 90 at the circumference. And now we are done. Y plus 55 will give us this 90, because they are complementary angles. So we take y plus 55 equal to 90, y will be equal to 35 degrees. If you can't do this in this way, you just add y plus 55 plus 90 equal to 180, and you still get your answer as 35 degrees. Now let us take the next examples. Let me take these ones so that we will not get back to them again. Okay. Now let's take the next example. Now, this is the next example that we are going to consider. We have this diagram. We have a circle. We have a circle. Let me bring it down small so that you will get it. Bring it down small like this. You have a tangent. No. Unless we draw the triangle and then we inscribe the circle. So let me draw the triangle. Just accept my drawing as this. Let me inscribe the circle. Perfect. Just take my triangle and my circle as it is. Correct. So we have A, B, C, D, E, F. We have the angle here to be 56, 58, and 66. Let me make sure that we sum up to 180. 66 plus 56 plus 58 is 56 plus 66 plus 58. Yes, the sum of 180. And we are to find y, x, r. So how do we do this one? Just a minute, try this for me to see. Yeah, you are there. You tried. Okay. Now, to answer this question, we need to know some more thing about tangents. You see that line BC is tangent to the circle at B. So the angle here, you see that the angle here and the angle here are the same. They are the same angle. They are the same angle. And that's here too. The angle here and the angle here are the same. Here to the angle here, they are the same. And here, the angle here and the angle here are also the same. Let me give you a very short proof so that you understand yourself. Assuming I draw a circle and then I draw this as a tangent. If I indicate here at the center of the circle, this is radius and this is radius. You know that the angle between the tangent and the radius is 90. So this one is also 90. Have you seen that? Yes. So if I draw a line through this, wow, you see that this one will become height. And that if I draw this line, you see that this one will be radius and this one will be radius. So the angle here, let me do it more bigger for you to see. Let me do it here. Bigger one for you to see, right? Yes. And then, so that you see it more clearly than what I was doing. So if you indicate here at the center, this is radius and this is radius. Now let me draw a line from here to here. You know that the angle between the tangent and the radius is 90. The angle here is also 90. So let's see that this is radius and this is radius. So this triangle becomes isosceles. So the base angles are the same. So the angle here and the angle here are the same. Are you okay? So if we assume that the angle here is 30, the angle here will be 60. And the angle here also will be 30. So the angle here also will be what? 60. Very simple as that. So that is why we are saying that The angle here and the angle here are the same. The angle here and the angle here are the same. The angle here and the angle here are also the same. So this is the property of a tangent. If you don't know, I've revealed the secret to you. Now, if we assume that this place is M, this place will be M. So we are going to have 2M plus 56 equal to 180. And that we will take 2M is equal to 180 minus 56, and 2M will be 180 minus 56 is 124 divided by 2 will give us 62. So 124 divided by 2, M will be 62. And then if we indicate here as Q, this place will also be Q. So you have 2Q plus 58 equal to 180, and 2Q will be 180 minus 58. Q will be 180 minus 58 divided by 2. Now will give us Q as 61. And now here too, if we come here, if we let here to be P, you have 2P plus 66 equal to 180, and P will be equal to 180 minus 66 divided by 2. That will give us P to be 57. So now we have P to be 57, we have Q to be 61, we have M to be 62. Now, we know that the angle that is from the alternate segment theorem, the angle between a tangent and a chord at the base of the chord is equal to the angle in the other segment, in the alternate segment. So here, the angle 62 is equal to the angle Y here. If you come here, the angle 61 is equal to the angle X here. And if you come here, the angle 57 is equal to the angle R here. And we are done. So Y is equal to 62, X equal to 61, and R equal to 51. This is equal to that, 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 this is equal to that. So wherever you stand, you get the same answers. And that is what we have there. So let's cancel this question and go to the next question. So I said, just keep watching. If you are going to write Wasi, Nobdek, any other exam that you are going to write, these questions will help you very, very well. So the next question is this one. To draw the circle. It also deals with a tangent. Deals with a tangent. And then there's another tangent here. And you have this to the point of tangent. You have this, that is 64, and the angle here is 85. Wow. You have to find this angle Y and this angle X. So how do we do this one? This is very simple. Now, a very quick method is the angle between the tangent and the chord is equal to the angle in the alternate segment. So we put it there. Y. Wow. And then the angle between the chord and the tangent is equal to the angle in the alternate segment. So here too we can put x here, and here the angle between the chord and the tangent is equal to the angle in the alternate segment. So we can put 85 here. Very simple as that. Now we are almost done. Very simple as that. And we've shown that the angle that the tangent will make here are the same. So here too is x. So we can find x here. So we have 2x plus 64 is equal to 180. 2x is equal to 180 minus 64. X is equal to 180 minus 64 divided by 2, and we get x. That is 180 minus 64 divided by 2 is 58. And we take the angles in the triangle, or you can take the angle on this straight line. So which of them will you consider? Any of them. If you look at this one, you have y plus x plus 85 equal to 180. Angles on a straight line, or you can take the sum of angles in the triangle. X is 58, so you have y is equal to 180 minus 85 minus x, and x is 58. So we have 180 minus 85 minus 58. That will give us y as 37 degrees. Very simple as that. 37 plus 58 plus 85 is 180. So our solution is correct. So let me cancel this one too. Okay, I hope you are enjoying the lesson. Let's move on. And let's take the next example. I think we are left with one. Yes. We've done 1, 2, 3, 4, 5, 6, 7, 8. So 8, 9. Okay, that left is only 2. So let's take this one. We have this nice circle, and we have diameter. This diameter. So let me assume the center here, and then we go here, go to this. No, we are not going here. This one, we are coming here, and then you come here, and you will come here. Correct. This is what we have, and this line is equal to this line, and you have this angle as 40. So what do? We have to find the remaining angles that we have here. Let's find angle x, angle y, angle z, and then angle, let's say, r. Now, how do you find these angles? Angle x is the first angle that I'll find, because if we look at this one, the diameter subtends an angle of 90. So angle x is equal to 90. And if you consider this chord, it subtends the angle 40 at the circumference, and the chord subtends angle z at the circumference. So z is equal to 40 degrees. Wow. So if we get z, this line is equal to this line. So the triangle is isosceles. So r is also equal to 40 degrees. That is base angles of isosceles triangle. Now we are left with finding x. So what do? So we are left with finding z. So we take r plus x plus okay, let me take z plus r plus x plus y equal to 180. that is sum of the angles in the triangle, Z is the same as R. So we have 80, that is 40 plus 40 plus 90 plus y equal to 180. This will give us 170 plus y equal to 180. So you have y to be equal to 10 degrees. Wow! Let's take the last example and then we see we are done. Okay, this is the last example. So check it out. Now this last example is this one. We are still on the tangents. This is the diagram. We have a line going this way, and this one meeting it, and then we have this to that. This is the center. We join, and then this line comes here. There's a line that comes here, and one can meet it at E. We have A, B, C, center O, and here is D. And what are we looking for? We are looking for this angle Y with this angle to be 25 degrees. So how do we calculate for angle Y? That is the last question. Now, what do? We want to calculate for that angle Y. That is very serious. Now, what we are going to do is that since here is 25, then it means the angle here is also 25 because this is radius and this is radius. And the base angle of an isosceles triangle are the same. So we can quickly find this angle. That is 25 plus 25 minus 180 will give us this. 25 plus 25 is 50. If you subtract it from 180, you get this angle as 130. Wow. We get our angle as 130. Now, we see that twice this angle will give us this angle. So it means that this angle is 65 degrees. That is the central angle theorem. Twice the angle at the circumference is equal to the angle at the center. This is 130. Now, we want this. So we are going to consider triangle ACD. Now, if you look at the angle here is equal to this angle. That's the angle between the tangent and the chord is equal to the angle at the circumference. The angle, at the circumference in the alternate segment. Very simple as that. So we are taking this one. Correct as that. So it means that this angle is 65 and we have the same thing here. That is also 65. So we take 65 plus y equal to 180 and we are good to go. That is 130. So y will be equal to 180 degrees minus 130 degrees and y will be equal to 50 degrees. And that is that. Thank you for watching. Please subscribe to my channel and don't forget to tap the notification button for more videos. Bye bye.